Hi, I'm Kido Oh. I'm now work for LGCNS. I've been worked in fields of smart city, smart building and mobility as a business development and a researcher. Today my topic is energy efficiency through smart city technologies. I'm going to start with the definition of the smart building because many articles use the similar concept as a different definition, which is intelligent building. Intelligent building concept was defined earlier than smart building, but I'm sure that two terms and definitions are most the same each other. The terms intelligent building was first used by the United States Building System Corporation in 1981 in the United States. Well, 2 years later, their efforts became a reality, and the Place building in Hartford, Connecticut, in the United States, was named as the first intelligent building. The building requires a really huge amount of components and technologies to build, operate, and maintain it. Smart building is an information technologies aspect in design, construct, operate, and maintain our building. Diverse types of buildings like hospital, hotels, schools, and many others are the place for the people's diverse activities. However, we usually classify the 4 categories and each sub-modules, as you can see this slide. Building energy management system we are going to deep dive today belongs to building automation part. The BEMS, simply BEMS, belongs to between the building automation and facility management system of the building. Recently, system integration part is more important than 3 part. Because the communication with the people having smartphone is really a good way to sense, operate, and maintain buildings. For example, people may find some problems or malfunctions of the facilities, or they ask to lower or higher room temperature, or they also may ask light on and off. Everyone has been thinking about the smarter buildings is necessary. It is very quite common ideas. Human usually imagine smarter and intelligent things. As this point of view, this approach is not far from the ideal. At the same time, wireless and IoT technologies is to make people demand technologies and smart devices more and more. At money-driven factors, definitely maximize values and optimize maintenance costs are very common nature in business area. I would like to focus on last items. Smart building technologies is now inevitable choice because of many obvious reasons shown in the slide, which was carbon neutrality is the state of the net zero carbon dioxide emissions. This can be achieved by the balancing emissions of the carbon dioxide, which is removable, or by eliminating emissions from our society. In addition, most of portion of greenhouse gas is carbon dioxide. So 3 terms has slightly different. However, I can tell you the aims of these terms are almost the same. In case of the United States, 79% of greenhouse gas is carbon dioxide. Among them, commercial buildings and residential houses generate about 13% of greenhouse gas. Korean government plans to use a combination of the regulatory measure and incentives in two-track approaches for newly built buildings and old buildings. They believe that there are many technical solutions and incentives at the same time. For example, wall-mounted solar panels could contribute decarbonizing power generation within buildings. Geothermal energy, hydropower, and waste heat from power generation and incineration could replace fossil fuels used for heating or cooling of the buildings. This slide shows that energy use in the building is more significant rate in global views of the greenhouse gas emissions. The city of New York enacted Local Law 97 in 2019 as a part of the Climate Mobilization Act. This is the world's first policy to regulate emissions in the city level. As you can see, graph right, within a city there are not much industrial and energy production. Share of the total emission is quite different from the country level greenhouse gas emission. So building is a major sector generating carbon emission in New York City. I believe the statistics would be similar in other cities in the world. The policy will hugely affect other cities to catch up or reduce nationwide greenhouse gas reduction policy. As you can see this slide, 40% reduction should be done by 2030. If building owners doesn't catch up these reductions, the fine will be charged for difference from the target reduction amount. Now, New York City offers a special service, which is NYC Accelerator. They recommend easy and many ways to achieve emission reduction shown in this slide. In one word, these mean buildings should have done like a retrofit buildings and adopt smart building solution. Basically, building requires energy from outside. In order to achieve net zero, there are three phases shown in this slide. The B is energy savings through design and construction level technologies like insulation or structural part of the buildings. The C is operational energy savings through building management system. The part is now deal with the ISO 50001. Finally, D could be compensated through energy production of the building. This slide shows how a building can achieve zero energy. Passive way means that building itself should have strong insulation and envelope technologies to minimize loss of heat or cooling air from the building. Active way means that building has its own energy production solution or heat recycling system. A building with BAMs would be classified into 5 grades based on energy independency. This grade will be criteria to get incentives from the government. However, we have 3 major problems to discover to move to zero energy buildings. The first, construction cost of a building is 30% higher than one having traditional concept of design. Second, period of the return on investment will take much longer. Finally, relatively new technologies might not be satisfied people's expectations in terms of the saving. To promote zero energy technologies, and building energy management system investment, Korea government offers various incentives to certified buildings as shown on this slide. Currently, mid-sized building like having 7 floors has over 100,000 tags. It is similar means with the data point. Most device has its own data to let us know the status, many parameters, and control values. The BEMS collects every data from the sensors and devices installed inside and outside buildings. And it monitors service index like room temperature and energy uses. And it also stores all historical data and support analytics functions to find any losses and excessive use of energy. This slide shows that the ideal comparison of the before and after installation BEMS effect. If we get energy savings after installation of the BEMS, we can estimate how much energy was saved. Adjustment in the slide could be produced by many factors not related with the BEMS due to special events or any renovations and modification of the building. However, in reality, still this analytical evaluation is not easy to achieve. There are some reasons. Firstly, in most of cases, baseline data could not be available or quality of data may not be good due to the lack of sensors or system. Second, if we get some energy savings, however, sometimes cost reduction is more persuadable for the building owner, which implies that optimization parameters could have multiple goals. In other words, building owners may focus more about the cost savings rather than energy savings. Finally, analytics is still very complicated due to the changing weather conditions and different amount of the usage like hot water consumption. The global BEMS consists of a physical part, including sensing and measuring devices, smart appliances and actuators, local renewable energy generation, energy storage devices, communication facilities, a gateway to allow to interconnect with other buildings, and the smart grid and the central processing unit. On the other hand, there is also cyber part comprising the different computing solutions which are based on the IoT, edge computing, and cloud computing. The energy management system must cope with occupant behavior in order to be really accepted by building users. In order to discover complexity of the analytics, deep learning techniques are a solution that is become more and more popular in recent years for BEMS. One interesting application is forecasting of the energy consumption in the building in order to implement adapt mechanism to optimize the energy management. In order to get correct, proper data, countless manufacturers produce sensors and devices for buildings. Each manufacturers and suppliers now use various types of communication technologies shown in this table. Besides, some sensors followed industrial standard message protocols, but some doesn't. So integration works to collect data and control devices isn't easy. So LGCNS offers very comprehensive solutions for smart building as well as BEMS, which name is City Hub Building. Building belongs to a certain area, exchange energies, data, and collaboration with community is very important to make it more efficient. This slide shows overview of the City Hub building. City Hub technically means that data hub for exchange data among all entities in a city. This is a very strong point. It could be interconnected with the smart city system. In this slide, smart enterprise is an engine that integrates, controls, and monitors the data collected from the Smart Connect. With distributed processing functions, users can improve the management efficiency by controlling not only single buildings but also several buildings in one main center and construct a large-scale control and monitor system by applying service for buildings. Smart Connect is a kind of I/O servers that collect and controls point values from devices. Smart Connect can communicate with the various devices. It supports more than 80 standard and non-standard protocols to expand the wide range of the device selection. In addition, it also provides diverse connectors for the various external systems. Smart Builder is an engineering tool for fulfilling integrated control. It consists of an authoring tool for data engineering of the devices and protocol profiles and production of screen, and runtime viewer for monitoring. Overall configuration is very flexible, so any types of buildings could be accommodated through City Hub buildings. Smart Viewer is basically for user operation. It has a HMI viewer, dashboard, stream analytics, and mobile monitoring. Device profiling is engineering tools to configure protocol types for device management and communication. There is control network settings, device information, control point information settings, and communication settings. View drawing is an engineering tool for graphic-based user screen drawing. It has screen object creation, screen effect processing, screen modeling, and screen rendering. And also there is a data collection, offers many functions for communication with devices. Collection data storage, collection intervals management, final status value management, and communication packet handling. Operation blocks provide user processing functions for monitoring, control, events, propagation, and actions, including mobile apps and the worker safety support functions. Monitoring blocks provides function of a viewer. It has network or device status monitoring, point values, trends, and alarms monitoring of data. The propagation block for broadcasting information to external systems and users. It has message notification and routing, propagation, channel setting, and session management of the propagation targets. Control areas for protocol communication with devices. It has control schedule management, control group management, control command execution management, and user script execution. Basic areas offers user management, permission management, system management, and web-based history search, which is user or role management and the system management. The finally tool block provides HMI UI builder, engineering tool, and smart connect agent and mobile hybrid web. Hotel Marcel is an architecture icon. The 9-story in New Haven, Connecticut. The Hotel Marcel earned a LEED Platinum certification from the U.S. Green Building Council in recognition of the design initiatives that significantly reduced its carbon footprint. It generates 100% of its own electricity, including the energy required for heating and hot water. This building has been renovated by innovative technologies, including power over Ethernet, digital electricity, and advanced HVAC and energy monitoring systems, and 1,000 plus solar panels installed atop of its rooftop and parking canopies. The energy storage system in cloud-based dashboards, allowing the building owners and facilities teams to monitor their system's performance and track actual savings and renewable production in real time. As you know, Tesla is famous tech company in the world. Now Tesla solar tire roof is available in the States. They offer very reliable and durable engineering products shown in this slide. This type of technology still has a pros and cons in terms of the capital cost and return on investment. However, it is a kind of innovation example for passive design. I believe that many new products will come out in the market soon. Thank you for listening.